Thank you.
Thank you.
So, I would like to welcome all of you here on this rainy day. Before we actually start deep diving into the depths of how we are doing the development environment itself, let me ask a few questions. First of all, who does not use microservices with their current work? Hands up. Okay, now that we know who uses microservices or does microservices, a quick question to the others. So who has more than 10 microservices? Okay, more than 20 maybe? Now the good news is that if you want to solve for a development environment, then this is the point at which you start to feel like feeling the issues that we are encountering at Prezi. Because the final question is that who has more than 100 microservices? Great. So in Prezi, we have at around 100 microservices, and this is why creating an efficient developer experience was kind of challenging for us. Now, the thing is that I'm not trying to advocate for microservice architecture or monolithic architecture. Our primary goal was to actually try to mix both worlds in the sense that things with monolithic architectures are easier, like debugging, basically building your services, and we wanted to bring that simplicity into the world of microservices. One final question. Who would qualify as a manager or a product person in the audience? Okay, some. So actually we will have content for both developers and both managers in the sense that you cannot separate this scale of change that we are going to describe from organizational matters to actual technology changes. So without further ado, let's take a look on what we are going to talk about. So first of all, we need to talk about this picture. This was actually taken at the Prezi office. So this will be our virtual workbench for the sake of this presentation. What we are going to start with is go over how the environment, how our services looked like before we founded our development experience team that Laci and I are working on. So Laci, would you mind going over what we had before?
Yeah, so Prezi began as a startup about 10 years ago. At the very beginning, we had a small monolithic services and a couple of awesome developers, and that's how it started. And then we started to add new features, new functionalities. So the monolith started to get wider, it became taller, until it reached the complexity that we had to do something. So we started breaking off small functionalities into microservices, and we started creating microservices of their own, which also meant that we started to have more developers. So teams formed around certain functionalities. And then they tried to solve their given area of expertise or these functionalities with the tools, the languages, and the frameworks that best fitted what they had to do. And this meant that services started to diverge. We started to have more languages, we started to support more frameworks, and the idea back then was that teams own their services. Okay, so again, things start to diverge, things start to get more complex. And then we started to move away from bare metal servers to the cloud, which again is a really cool thing, but it starts to add more complexity. And at this point, we started to spot patterns in the services. So here's when the idea came that, like, as good developers, if you start to spot patterns, you try to extract these functionalities out and not do the same things repetitively all over again. So there came the idea of have template repositories, which means that we started to generate services from the same code base. But we went a few steps further. We started to generate the CI jobs. We started to generate the infrastructure for services. So like everything, it was a whole package. But these template repositories or this code base, like the platform, began to have new features, new functionalities. We fixed bugs in them. But again, when you create a service from this template repository, that is a point-in-time snapshot of your platform at that given time. And if you add more features to the platform and then create new services, those will be a point-in-time snapshot of your platform at that given time. And as soon as you create them and start to develop the services, they start to diverge again. And if you want to add back the features that you added to the platform, you have to go back to those services and retroactively add these features again, which is very cumbersome and error-prone, and it's not fun at all. And it's a lot of mental burden to maintain these across 100 microservices, right? Yeah.
I mean, trust me, I have done that like at least 2 to 3 times for all of our microservices.
Yeah,
it's just great to ask for reviews for each and every service separately.
Yeah. So about 1 year ago, this is the state that we ended up in. So like half of our services were containerized and they were running on AWS Elastic Beanstalk, which is kind of a container orchestration tool on AWS. And the other half that we have kind of inherited from the bare metal era is those services that were chef managed, and now instead of bare metals, they were running on EC2 instances. And yeah, like a small amount of services, like I know the numbers do not really add up, so we were just as surprised as you are now to find out that there were some forgotten legacy services that were completely handmade and custom and very, very difficult to work with.
Yeah, so as said before, this is your workbench. Now, if you factor in all that we were talking about, this is how it does look like. If you take a look on this picture, just shouting, what is your first impression? Yeah, I heard something. Let me help. This is, at least in my opinion, is a mess.
Yeah.
Now, the thing is that you want to somehow create order in this mess. And if you would be taking a look on this from a user experience point of view, then you would say that this is messy. Now, with developer experience, you are having pretty much the same approach, but your primary customers are not our users, but rather our developers. And even though developers can handle this kind of chaos, it's better to not to bore them with such things. And of course, because now it's fashionable, Kubernetes solves everything. The problem with this picture is that actually it blocks the view. So let me get back to this in a few seconds. But before that, so to address this kind of mess, we actually decided, Prezi as the organization decided to found a team especially focused on developer experience. Now, this team is basically of 5 engineers. We had been working with this group in the last 9 months to improve the situation. And what we are going to show you now is basically the effect of this whole journey that we had taken. So how do you start doing developer experience? Not with solutions. You start listening to your developers. They are your customers. So what Laci was summarizing is actually the result of the feedback in the sense that these diverging baselines are the synthesis that we came up with. Developers usually just complaining about, okay, I had this script inside my repository and I copied the whole thing over and it does not work in my new service. But basically this is such a duplication that you shouldn't do, and this is when you start to think about how to actually solve for. This is how you get solutions. Another example was that how much time does it take to set up your development environment? Before we started to work on this issue, it was between a day for the fortunate and a week for the unfortunate ones. Now the thing is that we will show you in the second half of this presentation how we can actually make our first change in 15 minutes with the new system. But if you take a look on this, this is actually not a problem of the developer environment we had, but rather the diverging and uncontrolled freedom over the environment the developers have on their laptops. So we needed to have a solution for that. And of course, we need to have solutions. And this is where Kubernetes comes in, because it has a rich ecosystem for developers. But on the other hand, we also needed to start thinking about ways of working. I was mentioning that if you copy a script, then it was not working in the previous repository. Now the problem is twofold. One is that it does not work. The second is that you should not copy those scripts. Those are essentially boilerplates inside your repository. So instead, we started to converge into something that we call a declarative description of what you want to achieve. That script serves a function, like running your front-end tests, like running your integration tests, like having static asset handling in your repository. We should not ask the developers to reinvent the wheel. We should move them into a central place. Now, of course, if everything is done, let's not forget about education. The thing is that if you create such a thing and you want to be good at it, people start to rely on that. It will increase your support burden. And the way you can get around this is that you actually teach people how to use your system. So this is as well part of developer experience. And honestly, I wouldn't expect a newcomer, full stack engineer, or basically anybody in the company to know Kubernetes in and out, or the tools that we are going to show you soon. So how do we achieve this? First, we needed to centralize. Centralize because this is the only way we can get rid of duplications inside the platform itself, because the platform also a code base that you want to make sure that is clean. This is not something that the normal programming rules does not apply to. Also, as Laci was already mentioning, we had a DevOps implementation that said that each and every team has end-to-end responsibility on their microservices. This means that they are responsible for it to build, how they build it, up to the point at which it has issues in production. Now this results when having 100 microservices that you, as somebody who is wishing to contribute, also need to go over each and every service. This is what we wanted to break up, and that's why we had this declarative kind of approach. This way, if we find something that is actually used in 2 different services, we can say that, okay, instead of maintaining your own code base, let's gather the knowledge you already created, let's move it into the central platform, and then we will be able to open that up to other developers that will eventually need that. Now, we also need to have a certain level of uniformity. And don't get me wrong, so we are not talking about killing all languages other than Python, Scala, or assembly, or whatever language you want to program in. What we are talking about is that, yes, Prezi is inherently a polyglot company, and we view that as a value, and that value needs to be maintained. But we should only support those languages that have enough support in our community, and that we can centrally manage so that people will be able to work on what is important to their daily jobs and not on platform level things one by one. Also, uniformity is convenient. It's convenient for the developers themselves, because if you can expect a service to behave pretty much the same way from the platform perspective than another one, then you will not have to have those mental notes that you were seeing on the workbench, and this way you can easily touch a service that you had not been touched upon before. Like this is basically a promise of Scaffold, for example, and we are trying to take that to the next level. Now, just to tell you an example why this is important, it was just yesterday that one of our researchers came to us, the developer experience team. At Prezi, researchers are not really backend developers. They are working on theories. They are working on experimental features, descriptions, mathematical background, and stuff like that. And he approached us that, okay, we have this strange beast service that is basically really on the periphery. We did not really do any certification for this PDA platform on that. We quickly checked, and it was uniform with the latest baseline. Then we said, okay, let's set up your development environment. 15 minutes passed. He went away happily. In half an hour, he was showing his first change to us. being a complete stranger to this whole world that we are detailing. Also, you need uniformity on the environment itself. This is why we started to use a remote Kubernetes cluster for the whole thing that you are going to see. We are not messing with local installations because our experience is that the Dockerize, the microcase, the other implementations behaving differently. So this way we are trying to make our lives easier and the developers' lives easier. Now that we got over what DX is about, I would recommend that we move on to a small demo, which I'm pretty sure all of you were waiting for. So for the sake of this presentation, I will be a junior developer who has just joined Prezi. And my product guys basically tasked me to change the login button on our Prezi login page, because that's not conform to some regulations. And Lotzi will be my help in this because he's a DX member and my support request just came into him. So Lotzi, I need to change this login button. I have my fresh laptop. I need to change it fast. How do I do that?
Yeah, okay. So there's this tool called PD that is an acronym for the Prezi development environment that the DX team has been working on for the last couple of months. And for the sake of convenience, here's your laptop. It's a basic Ubuntu Bionic machine, and we have pre-installed PD in it for you. Okay, so imagine that not just services get diverged, but each developer is setting up their own development environment, and everyone is solving it in a different way. They install a different version of tool. They have a later or newer version of Python or Java or whatever tool that they use. So PDE comes batteries included, which means that it has the capability to install the tools that we use in the background, and they install them in the exact same version that we have been tested and proven to work together before. Okay?
Okay, sounds great. So how do I do that?
Yeah, so this is very simple to do. So you just set PDE in it, and you need to pass just one argument to it, which is the namespace.
And what's the namespace?
Yeah, so namespace is an isolation or...
Oh, it failed.
Yeah, okay, no worries. So the demo gods are with us. This is just a timeout issue. Let's try it again. Okay, there you go.
Yeah, this
one more thing, it's asking for your password because it's, of course, installing tools on your machine. So let's just give it the password, and here we go. Okay, so while we wait, it takes just a minute, but let me explain what's happening to you here. So namespace is an isolation in Kubernetes, which means that you have your own sandbox in the cluster where you can deploy your Prezi ecosystem, like your own services. Each developer has its own, but it has a lot of other functionalities that we can use it for like later. We can create disposable environments in a matter of minutes to use for end-to-end testing, or to use it for stress testing, or for whatever purposes we would like. And to set up your environment, we use Ansible to install all the tools. And for example, we also set up certificates for you. We set up your SSH config and keys and everything you need to start working right away. And of course, since we use Kubernetes in the background, we install the Kubernetes CLI for you. We install Helm, which is a package manager kind of for Kubernetes. We will talk a bit about it later. And we will also use Scaffold in the background, which is a pretty new tool that is it's an open source tool, but it's backed by Google and kind of developed by Google. And this is a tool that helps you develop microservices in your Kubernetes cluster right away. We will talk with details about them later. So let's see how's it going. Okay, so your environment has been set up.
Okay, cool. Great. So now how do I change that login button?
Yeah, okay, so first, we have this notion in PDE of deploying services in two different modes. One is called the dependency mode, and the other one is called the development mode. Okay, so first we just want to fire up a small Prezi ecosystem and a couple of services, right? And this is like very simple to do. This might be a mouthful first, but...
wow, that's many for services.
I will explain it very soon. So you just basically say that PDE, you say dep, which means you want to bring up these services in dependency mode, and a list of services, an arbitrary number of services that you want to fire up. And while it's working, it takes about like 2 minutes to bring up this many services. Let's see what's happening in the background. So there are a couple of services that we bring up, like the cover page, like dashboard, just for the sake of this demonstration for you. And this is login service that you want to develop, right?
Definitely.
But microservices, sorry.
That's
okay.
where the button is, yes.
Yeah, okay. So login service. And microservices in nature depend on each other. They're calling out to other services, and those services are depending on other services. So they have transitive dependencies, and this is no different for the login page either. So it's trying to communicate with the authorization backend. And the authorization backend is trying to create sessions for you, and it's creating, writing, and deleting tokens in the background. It needs to know about licensing information. It needs to know about some payment information. So, but you don't want to bother with those services. You just need them because you need them, or because you need those services to work with login service. And you don't want to have these repositories checked out on your machine. You don't want to bother how they deployed. You just need them. And we install them to the Kubernetes cluster with Helm. Now, Helm has this notion of charts. A chart defines how a service is deployed to your Kubernetes cluster. It describes how much resources you need, how much memory, how much CPU, and a lot of other things.
So then do I have to write like the Helm chart manually for each and every service?
No,
or?
because all of our services now in a common baseline, which means that we deploy all of them with a single Helm chart. So one Helm chart that fits all of our services.
Okay, got it. So
Yeah,
how
and you do not need to touch them. Okay, so to answer your question,
Great.
no need to change them. We even like these images, we pre-build with our CI system, and the Helm chart is also available for everyone to use.
Yeah, and do I need to have the sources of these on my laptop?
No, none at all.
Okay.
At this point,
that's a lot of repositories to clone.
yeah, you don't need them. Okay, so let's say how's it going. Okay, so we have our services deployed to our cluster. Let's check if they are in a running state. Okay, so this is a simple kubectl command, and it's checking your namespace, and all the services are up and running there. Let's check it out, okay? And remember that we use the namespace craft for you now.
Yep.
Okay, so this means that each developer has a private URL that is only available, of course, in our private virtual private network. And you just simply say that craft.prezi.dev. And let's check it out, what happens. Okay, so this is the front page of Prezi, and we brought up with two very simple commands in a matter of a couple of minutes. And it's fully functional. It's all here, just like the real Prezi front page. But you want to change login page, right?
Yeah,
Here
that's
it
the
is.
thing I want to change, that login.
Okay, so this service is running in dependency mode right now, which means that you cannot change it. It's there for your Prezi ecosystem. And now, let's bring up this service in development mode. This is, again, very simple. Just like PDE dev, now you say PDE dev and the name of the service, which is login service, and you hit enter, and there you go. Again, this takes a couple of minutes. Let's see what happens in the background.
Seems easy.
Okay, so this is done by Scaffold. So Scaffold has a very simple workflow. What it does that you have, for example, a Docker file, and Scaffold builds the Docker image for you from the source of course. So to develop a service, you have to, of course, have the source code in your machine that you will change later. And it has a Docker file, and Scaffold will generate the Docker image.
Yeah, so I suppose we were
for you.
cheating by having that repository on the machine, right?
Yeah, sorry, I already had it checked out for you. Yeah, so once we build this image, we push this image to a repository that is available for your Kubernetes cluster. And then, again, using the same Helm charts that we use to deploy the services in dependency mode, using that chart, we deploy and replace the service in dependency mode with the same service that's built from your local source. In your cluster, we replace it, and then Scaffold enters a kind of a watch mode. Now, this watch mode means that it's looking for changes in your repository locally. So this means that it's just a file changes, two things can happen. And this also means that you can use whatever editor you like.
So like I can use IntelliJ or VS Code or whatever.
Yeah, whatever you like.
Great.
You make your changes, save the files, Scaffold will detect it, and at this point, two things can happen. One thing is that imagine that you change a file, like you make change to a picture, or you change an HTML file, or something that does not really need recompilation. In this case, based on a set of filters, Scaffold will sync this file up into your running container live, and that's it. Basically, it's up there in a matter of a couple of seconds, and your change is in your running container.
Yeah, if your environment actually supports this kind of hot reload functionality, I suppose.
Yeah, we will get there. And the other thing that can happen, that imagine that you change, for example, a dependency. Like you add a new package, or you bump it to a newer version. In this case, the container maybe needs to be rebuilt, right? So Scaffold will see it and get back to the beginning. Based on the same Docker file, it will build the image, push it, deploy it using the same health charts, and replace your container in your cluster. And yeah, so above Scaffold, we generate an overlay with PDE. This means that the Docker files I talked about, it's not existing in your repository. And the Scaffold exists.
But then should I even commit those, or?
No, none at all, because again, those would be point-in-time snapshots. And if we need to make a change, again, going through 100 microservices manually is very cumbersome and error-prone, and it's not really a good practice. So that's why we generate.
Okay, so I'm always getting the latest up-to-date version of those, right?
That's right. That's what we mean by having this centralized inside PDE, one single tool. So you just, to get the latest features or bug fixes, you just update PDE, and next time you run a service in dependency or development mode, you get the latest features. Which means that, for example, we generate the Docker file for it. We generate the Scaffold descriptor, or we also generate even the entry point for the Docker file. And which means that, for example, this entry point is what's supporting, like, for example, this hot reloading or debugging inside the containers.
So can I debug with IntelliJ, for example?
Yes. So
Great.
in Prezi, IntelliJ is one of the primary platforms that we use for developing, and currently this is the platform that we support for debugging, but we can easily add support for other platforms or other development environments. We commit into this to PDE, everyone updates, and then you can use your favorite editor to start debugging your cluster.
Okay, but still we are in a kind of hurry, so I need to change that login button.
Yeah, sure. Okay, so how's it going? Okay, so it seems that the service already started and was replaced in the cluster. And yeah, so this is the source code for the login page.
Can I do that?
Yeah, sure, please do. What do you want to change it to?
Shoot, I forgot to ask my product guy.
Okay, no worries. Let's change it to something that suits the occasion, right?
Okay, maybe hello craft. Should be fine.
Okay, so
Then
now you made the change and saved the file. So let's see what happens. Okay, so it seems that Scaffold already detected. You can see it at the bottom that there was a file, and it synced it up to the container, and now it's getting back to the state where it's watching for additional changes. Okay, so let's just hit refresh here. And in development mode, we cannot do some build time optimizations on the container, so it takes a little more time for them to load. But there you go. Here's your change. Hello, Craft.
thank you. You saved my life today.
Yeah.
So so then one final question. What if
Please.
it breaks? I mean, it's nice that you've shown me, it's nice that I was not doing that, you set it up for me, but if I go back to my workplace, how do you detect if this breaks?
Yeah, so we have telemetry included in every part of this, this tool, which means that if something breaks, like an unexpected exception happens, we see it in Sentry. Or we also see the happy path, which means that you may have seen that whenever we start a PDE command, you can see the first line you can see is a generated unique ID, which is the telemetry session ID, what we call. And this is a unique ID that's unique for that execution of the tool. And we apply all these, so whatever resources in, for example, in the Kubernetes cluster, PDE creates for this execution get labeled with this unique ID. So we can see everything, like, so what's created by the service.
Deployment times and all the metrics that actually important for the developers themselves.
We can make correlations between what was created by this given execution.
Either ways, let me turn back to the lesson knowing myself. And let's talk a bit about one last thing, because if you were listening carefully, we started by diverging baselines. And the thing is that in reality, you will not be able to get rid of all of the boilerplate codes that you are having inside your service repositories. Now, if we want to solve for that, there are ways doing that. For example, what about upon onboarding trainings, asking the developers to write this down like 100 times? Okay, it will not work. So then, what should we do? Actually, Python has a great tool called PyFlakes, and we thought, what about we want to do something like this? Now, the general concept is valid for basically anything. You can pick your language. The only reason why we picked Python for implementing this kind of tool is because the company mostly uses Python. You should always use the tools that others can actually contribute to for your company. Now, what you are seeing is a check for the tool from the tool that we call the conformist. And we use this tool to run against microservices repositories every week, basically. And this is proposing patches to the developers themselves. This way, they don't need to keep in mind what has been changed. We have a pragmatic description of what we expect the baseline to look like. Now, what are we seeing here? First of all, again, we are polyglot. This one is valid for multiple stacks. There are stuff that is only valid for a single stack. And what we are stating is that each and every Dockerify.production, this is something we are to phase out with the overlays though, there should be this line. Now, we are not just stating that it should exist, but we are giving instructions where to put it. This way, based on this data, we are able to generate commits and pull requests like this. As you see, description becomes commit message, and the actual change will be this line or the zero effort from the teams. The only thing they need to do is to actually merge those pull requests. Now, this set aside, what we have learned, first of all, you need to listen to developers. You should absolutely focus on what they need and not on stuff that you would feel like fancy to be implemented. Because actually, the best code, the best feature you might have or you could maintain is the feature that does not exist. Don't overdo it. Just do the bare minimum. This way you can help them. Also, this whole thing couldn't have happened if this developer experience team hadn't been founded. This means that you need to have focus. You need to make the problems into a scope of a team. And this gives you ability to actually react on changes, because platforms do change. I don't know what will be the next generation of Kubernetes, even if that will be Kubernetes. And the thing is that if you start centralizing, people will come to you, developers will come to you, and will ask for new features. Now, if you are making your platform static, you are freezing it and working on the next generation. Or if you start basically neglecting those requests, you will end up in a way that people, and developers are clever, will re-implement those features that should be central inside their own repositories, and this whole diverging process starts again. This way, you actually need to support them and support the change and be fast on changes, or you cannot really satisfy their requirements. Or think about security. Security team tends to roll out changes. You need to support that. You cannot say to them that, okay, we are architecting our next platform, it will be done in 2 years' time, please bear with that root exploit. This does not work. So this is what we wanted to cover. This was basically László Üveges from DX team.
And Péter Turi from the DX team.
And you know the drill. If you are interested in working with this in this environment, then this is the link for you. And now I suppose it's Slido time then. Okay, so the first one is, this seems like a lot of repository-specific tooling. How difficult it is to add a completely new microservice into the system, possibly a new language or framework. So it really depends on. One thing is that this is not repository-specific. It's not repository-specific in the sense that we are trying to move away boilerplate from the repositories. That's why we have the overlays, that's why we have a centralized build flow that we are capitalizing on. So the repository actually does not contain too much stuff inside. Now, adding a new microservice in this way means that you are cloning the still existing template repository, and it works. That's all, because we are unified. Of course, conformist needs to be run regularly so that it can keep up with the changes. For new languages, that's a different story. You need to provide the Docker file for that language. That's the activity you need to do. We are relying on Scaffold. Scaffold is well able to build anything you can describe in a Docker file. Debugging support might be a bit trickier, but for now, it doesn't seem to be too hard. That's it. Next one. How do you ensure that tests can be executed on every environment? Are they part of the setup? So, yeah, regarding tests, we do support unit tests, that's for sure. Actually, we also support running some of our integration tests on the system, but this is an isolated system as of now. We are using MariaDB in background and emulated DynamoDB sources, so it's trying to resemble the production system as much as possible. Still, later on, we are planning to have a more production-like implementation as a next level of verification. But right now, I'm not aware of any test that you cannot run against this system with these limitations.
Yeah, and if I may add something.
Please.
So first, we decided to move all the services. Like, remember, we had 2 separate platforms before. And then first, we moved everything to the common baseline. And then we decided that it would be really great to move to Kubernetes. But it's not like moving, okay, let's start moving production things into Kubernetes. But we decided to use this LDE project to get experience with Kubernetes. And then, using this experience, later we can have a better production system.
Yeah, definitely, and that's why we are using Helm even for this. So this way we can reuse those Helm charts for production systems later on. We should minimize the differences because then it makes zero sense to verify or to develop against such a completely different system on the long run. Is your environment supposed to be temporary, or do you expect developers to create one and use for a long time? How do you deal with upgrade? So that's a great question. The environment itself, like the Kubernetes cluster, is permanent. Of course, we are upgrading that. But for the services running inside, our official standpoint is that at the end of the day, because this is an AWS auto-scaling group basically, you should destroy your environment and bring it up the next day. This actually solves all of our upgrade issues because the next day people will just deploy with the new images. On the other hand, this is not happening, so we are kind of trying to somehow educate people that they should actually bring down their clusters, or we might do that from them. Either ways, upgrades are kind of easy this way, and PDA has exact pinning for all the software versions, and we'll have for the Helm charts as well, so that we can actually control what baseline they are using by a single PDE release. That's why we are using Ansible.
Okay, we have no more time
for
questions.
If you
So thank you so much for coming and presenting. This is a little gift.
Thank
Actually, this one is yours.
Thank you very
This
much.
is yours.
Thank you very much.
So